Hi everybody, welcome back to our Calculus 1 Summer B 2020 course. This is the introduction video for week 3. Hopefully everyone has finished exam 1 by the time you're watching this and sent me all your work. Did a good job with doing all your work on scratch paper and send it to me because a lot of scores go way up after I deal with partial credit from looking at your work based on what I see. My math lab does a real bad job with that, so please, I've asked you many times, but get your work to me if you didn't. You're supposed to send it to me at the end of the exam, but if you haven't and didn't send it to me, make sure you get it to me. Okay, so that said, what is week 3 going to be about? So in the first section of week 3, section 3.3, we're actually getting into some rules for taking derivatives. Okay, so you actually know that the definition of the derivative f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. But there are actually some rules where we don't have to apply that limit, and you really will never apply that limit again. It's really just understanding what the derivative really is, the limit of the secant lines as they're approaching the tangent line. But from now on, when you do derivatives, you're going to be able to apply these rules. For example, the derivative of any constant is 0. The derivative of a power of x to the n power is n times x to the n minus 1. In other words, x squared, you bring the 2 down, you subtract 1 from the exponent, so it's 2x to the 1 or just 2x. X to the 2/3, you bring the 2/3 down, then it's x to the 2/3 minus 1, so that's 2/3 x to the minus 1/3, etc. So that's what's called the power rule. Then you have the constant multiple rule. If I have a constant in front of anything, then I just pull the constant out front of the derivative. If I have the sum rule, I can take the derivative of each one individually. And anyways, there's more rules. The product rule, very important. The quotient rule, also very important. And then kind of putting everything together using several rules at once, you need to be able to do too. And then you can take a second derivative or a third derivative or a fourth derivative, and that's what we're talking about in this section. Okay, so that's the first set. That homework, by the way, is due on Wednesday, not Tuesday this week, because you have your first exam on Monday and Tuesday, or Tuesday, whenever you take it. So that homework I didn't make due until Wednesday, just to make sure you can get back up to speed after dealing with the exam. Okay, then the second set of notes and homeworks, homework 8, which is due Thursday, sections 3, 4, and 3, 5. And in here, we're going to be kind of talking about the derivative in different ways. Okay, we're going to talk about motion along a line, displacement, velocity, speed, acceleration, and jerk, how these things are related. So displacement is essentially your position. Velocity is the first derivative of displacement, or your position, and speed is just the absolute value or the magnitude of velocity, because velocity gives a direction. Speed, just, you say I'm going 10 miles an hour, you don't say which direction you're going, that's your speed. If I'm going 10 miles an hour in that direction, specific direction, that's velocity. Okay, so what is velocity? It's the first derivative of displacement, etc. And then acceleration, you'll see, is the second derivative of displacement, or the first derivative of velocity, however you want to look at it. And again, go through this slow, make sure you understand everything, but I just want to get you to understand that there's some things that we want to be thinking about when it comes to using derivatives. And then derivatives in economics. So I wanted to make sure you got exposed to a little bit of things that can happen with economics when we need derivatives. Okay, so that's the second set of homework due Thursday. The third set is going to be sections 3, 6, and 3, 7. And in here we're going to get into something called the chain rule. The chain rule is another very important rule for taking derivatives. It's something probably a little bit more complicated to get used to at first. There's 2 different kinds of notation. I talk about this in my notes. This is like Newton notation here from when Newton invented calculus, and this is Leibniz notation from when Leibniz invented calculus. I think I tell you the story in my notes, but they both invented calculus in the 1700s, only about 8 months apart from each other, and they didn't have any idea each other. Mankind was ready at that point to understand calculus, is how I've always put that in my own mind. So different notations sometimes you'll have to deal with. And then using the chain rule. So I won't go through it right now. Make sure you listen to my videos and go through it. And then in the last section of the week, section 3.7, is something called implicit differentiation. So it's essentially the chain rule. It's just that when you have an equation like this, notice that we don't have it as y equals f of x. We just have x cubed plus y cubed minus 9x, y equals 0. So solving this for y is either really, really hard or maybe impossible. A lot of times actually impossible. But we still want to find dy dx as though it was written as y equals f of x. So this is an implicitly defined function, y equals f of x. So we need to use what's called implicit differentiation. And I'll explain that later in the videos as you watch and understand what's going on with this. So that's really, I just gave several examples because it's kind of a complicated concept here. And that's the end of week 3. So again, don't hesitate to reach out if you have more questions before you take the exam tomorrow. I have office hours from 1 to 3 on Tuesday. But of course, you guys can reach me anytime. I've already helped a lot of people outside of class, so don't be afraid to reach out to me. Okay, that should be it. And good luck with week 3, and I hope you all did well with the exam.